Hi, this is lesson chapter 5 from the core text, the first lesson A from unit 1. We're going to be using the core book first for the majority at the beginning, and then we're going to switch over to the Ibsl book. And we might go back to the core again. We might jump around a little bit, but this is the first part of the MHF4U7 course. And the first lesson here is on number sequences. And you may know from learning multiplication tables in the past or multiplication facts, certain skip counting and that kind of thing. So, whether you go 2, 4, 6, 8, etc., or 3, 6, 9, 12, 15. So you could even go into the negatives as well and start, say, at 10, 8, 6, 4, 2, 0, -2, -4, etc. So sequences can take all kinds of different forms. It could be numbers, like I've been illustrating. It could be patterns of words or letters or whatnot. Some of them can be pretty straightforward. Other ones might not be so straightforward. So basically, we just have to kind of take a look at them and kind of figure out what is going on with these number sequences. And number sequences are made up of what's called members, and I will highlight that word. So members of each of the sequence, members are basically terms, and the term is in a specific place, a defined position. So think of maybe cells of a spreadsheet, and if we were to, I'll just do something very quick here. Whoops. So if we have a bunch of cells in a spreadsheet, the numbers could, here's cell 1, or position 2, position 3, 4, etc. And then, of course, the values could be something like the value in cell 1 could be, say, 6. The value in cell 2 could be 11. The value in cell 3 could be 16, then 21, 26, etc. So the members or the terms are 6, 11, 16, 21, 26, etc. The position would be 1 is terms, the term number, sorry, the term, which is 6, is term 1. So this is the term number. And this is the term itself. So the first term is term 6, the second term is 11, third term is 16, the fourth term is 21, etc. So that's what it means by position, is the position in that sequence. And it follows some sort of mathematical rule. In this case, there is +5 between each one. Okay, so we see that there's some kind of rule that it follows to go from one term to the next. So that's a fairly basic one, but that sort of illustrates what we mean by the term and the position, or the term number that they are, and the mathematical rule that they follow. Okay, so for the first example here, oh, sorry, just to quickly look at this. Infinite sequences go on forever, hence they're infinite. And finite sequences have a definite termination point. Okay, so they will end at some point. If we take a look at this example, 480, 240, 120, 60, we want to write down a description of the sequence, what's happening from one term to the next, and find the next two terms. So if you take a look at from going from 480 to 240, what's happening there? And then what's happening from 240 to 120? Usually the first, now in this one, this sequence is fairly straightforward, but a lot of times there could be a variable number, or a variation of different things that could go on between the first term and the second term. Then if you test the same rule to go from the second term to the third term, that's usually when you'll confirm that you've got the correct rule. And then you can test it to go on to from the third term to the fourth term. So from 480 to 240, and then 240 to 120, what do you think is going on there? So basically, it's divided by 2 each time, and we can, so 480 divided by 2 is 240, 240 divided by 2 is 120, 120 divided by 2 is 60. So I think we're pretty comfortable that that would be the correct description of what's going on. And I guess, I mean, if you're supposed to write it in words, I guess we could say each successive term or subsequent term, perhaps, is found by dividing the previous term by 2. Okay, so successive or subsequent, something like that. Okay, so that just means that we start with one term, we divide by 2, we get to the next term, okay, etc. And then to get the next 2 terms that we're trying to find, well, 60 divided by 2 is then, of course, 30, and then 30 divided by 2 is 15. Okay, so then I guess we don't know if it does terminate, so we could put the ellipsis saying that it's continuing, sort of ignoring this previous ellipsis. It's going straight from 60 to 30, and then from 30 to 15. Okay, and they can just continue. Moving along here, we've got another number pattern. We got 2, then 6. So if you take a look at that, we could say there's just like I said up here, there's multiple different ways to go from 480 to 240. You could have said, well, we subtract 240 from 480, but then if you subtracted 240 from 240, you wouldn't get 120. So you have to kind of go back to the drawing board and rethink things, and that's how we got to the division by 2. Here we've got a number of things we could do, a number of ways to go from 2 to 6. So we could think of this as saying, okay, well, from 2 to 6, we could maybe multiply by 3. Or we could add 4. Okay, so there's a couple ways of looking at that. But then when we go from 6 to 12, well, the multiplying by 3 doesn't work, because then we should end up with 18. And adding 4 doesn't work, because otherwise that 12 would be a 10. Okay, so multiplying by 3 and adding 4 doesn't seem to work for this next step. But what else happens here? Maybe if you go from 6 to 12, well, okay, so we could multiply by 2. Well, so far the rule's changing already, so the multiplication part may not work. And again, if you look from, and I'll just put little arrows here. If you go from then 12 to 20, well, we're definitely not multiplying by 1. We're definitely not multiplying by 2. Could we multiply by some sort of decimal? Perhaps, but that kind of gets a bit more messy. Well, what else happens here? We could say, okay, from 6 to 12, if we go the addition route, from 6 to 12, we're adding 6. Okay. Oh, so here from 2 to 6, we added 4. From 6 to 12, we added 6. What about from 12 to 20? Oh, I see. Well, okay, well, maybe we're adding 8. Okay, and then the next one, we'd be adding 10, perhaps, and then adding 12. Okay, so we look at it that way and say, you know, there's a few different ways to look at it and see if there's something consistent. And this one seems to be consistent, where the difference between terms is increasing by 2 each time. Okay, so the next 3 terms, so we got 30, then 12 added on to 30 is 42, and then I guess we would be adding 14 next, and that would then give us 56. And then add the ellipsis, thus continuing on the sequence. Okay, so it doesn't have to be just a constant rule like this first example where we're dividing 2 for each term. It's still a rule, it's still a mathematical rule, and we see that things, we're adding 4, adding 6, so we're still adding, but we see that there is a pattern in what we're doing, so we just increase what we're adding to each term. Okay, so that's just another number pattern. So we can say here, what each term is found by adding, how would you write that? Adding an increasingly larger value, perhaps. Or more specifically, adding a value that is 2 larger than the previous difference, perhaps. Okay, so there's different ways of describing these patterns. Okay, but that's kind of how you would go about and do that. And this could be an alternate way of saying that, but maybe a more specific way. And generally, we'll be looking for specific ways of describing the number patterns. All right, moving right along here. Now, the general term is basically, it's when we take a look at, I'm just dropping back to the first page again, we take a look at this, and the general term is finding how each term relates to its position in the sequence. So we start with term 1. The very first term is always term 1. There's never a term 0, but term 1 has a certain value, term 2 has a certain value, etc. So when we look at general terms, what we want to do is we want to see, well, how in the world does the term itself relate to the term number? So when we look at this, we want to see how does -5 relate to the first term? And the subscripts here, in general, what we say, the terms would be u sub n. So we see, well, what does that n do to get that -5? Or how do we use that n, which ends up being the actual subscripts, the values of the subscripts, 1, 2, 3, 4, etc. How do we use those subscripts, the n value, to get the actual term? Because once we can get the general term, which is generally the trickiest part of finding a sequence, once we can get that, and once you practice at it a little bit, it gets a little bit easier, but the first few times it might be a little bit challenging. So you kind of have to look at the value, the term, look at the term number, see, well, what can I do with that 1 to get -5? And then you want to test your rule to see if, what can I do with this 2 to get that -1? And is it the same rule again to use 3 to get +3? And to get that 4, the n value 4, to get 7. So we're using the n value of 1, 2, 3, 4, etc., to get the actual terms. So we could take a look at this 1 and say, okay, well, what could I do? I could say multiply n times -5, for example. Okay, so we could try and say, okay, well, this rule could be the general term. That's how we write the general term, is -5n, where n is the term number. Okay, so that works for the first term. Does it work for the second term? Well, the second term, n is 2, so 2 times -5 is not -1. Okay, so this rule is obviously wrong. Okay, so we have to go back to the drawing board. Well, what could we do to get this? Could we take the n and multiply by +2, just for kicks, +2 and subtract 7? So could we say that t sub n is 2n minus 7? Okay, well, if n is 1, 2 times 1 is 2, minus 7 is -5. Okay, so that works for the first term. Will it work for the second term? Well, let's see. N is 2 in this case, so 2 times 2 is 4. 4 minus 7 is -3. It's not -1. Okay, so it's off. Maybe it's getting a little closer. Maybe we could multiply by 3 and subtract something. So there's a bunch of different ways. I mean, you just at the beginning, just a little bit of trial and error as we try to find what that general term is. And just to kind of state what each of these terms are. Term 1 is u1, which is -5. Term 2 is u sub 2, which is -1. Term 3 is u sub 3, which is 3. U sub 4 is 7. U sub 5 is 11, etc. Okay, and as we continue scrolling down here, as it turns out, we were on to something when I stated t sub n, or the general term, is 2n minus 7. As it turns out, it's the general term, or u sub n, I suppose, is 4n minus 9. So if we test that, if we substitute 1 in for n, well then 4 times 1 is 4, and we subtract 9, we get -5. Okay, that's the first term. 4 times 2 is 8, subtract 9 is -1. Okay, so we're on to something here. 4 times 3 is 12, minus 9 is 3. Now, I have to apologize. This is not the correct format of doing this. I should be saying u sub 1 is 4 times 1 minus 9. I should be writing the whole expression out. So sorry for my laziness. And that gives us -5. U sub 2 is 4 times 2 minus 9, which gives us 8 minus 9, which is -1. Okay, so this is the correct form of checking the general term. Okay, not this way I was just doing it at the beginning. Okay, so if you write out the expressions like that, and then so that shows us how the term number relates to the actual term. So term 1 is -5, term 2 is -1. If we substitute 3 into this, we'd get 4 times 3, which is 12, minus 9 is 3, or so term 3 is 3, etc. Okay, so it's going to be a little bit challenging perhaps at first, but then just have to kind of keep playing around with it until you end up getting the correct expression for the general term. And we'll be doing a lot of this when we get into lesson 5B when we're talking about arithmetic sequences. Okay, let's move along. Here's a sequence defined by u sub n, which is 4n minus 9. Oh, big surprise where we saw that before. And u sub 3, we have to find u sub 3. Okay, so that's going to be 4. We substitute 3 in for n, subtract 9. So we got 12 minus 9, which is 3. So third term is 3. U sub 15, so the 15th term, we got 4 times 15 minus 9. 4 times 15. Try to do that in your head without your calculator, please. 4 times 15, 60, minus 9 gives us 51. Okay, and then this the second example, evaluate the first 5 terms of this sequence, 2 sub n, or 2n minus 1. So the sequence would be, so n is 1 at first, So 1 times 2 is 2, minus 1 gives us 1. The second term, 2 times 2, which is 4, minus 1 is 3. Third term, 2 times 3 is 6, minus 1 is 5. The fourth term, 2 times 4, 8, minus 1 is 7. And you can sort of guess that 9 would be the last term there for the fifth term. And then evaluating the first 5 terms of this sequence. Okay, so now we've got exponents. So we have to obviously do the exponents first. So 2 to the power 1 is 2. 2 times 3 is 6. Then n is 2 for the second term. So 2 squared is 4 times 3 is 12. The third term, n equals 3. So 2 to the power 3 is 8. 8 times 3 is 24. 2 to the power 4, so n is 4 for the fourth term. 2 to the power 4 is 16. 16 times 3 is 48. And we could guess here that the fifth term would be 96, but let's take a look at this. 2 to the power 5 for the fifth term, n is 5, so 2 to the power 5 is 32. 32 times 3 is indeed 96. Okay. So that's the end of lesson 15A, or sorry, 5A. And I don't really like giving homework, so I give you class time fun. And so when there's a little bit of time left in class, I like you to go through some of this work. All these questions have been chosen for you specifically to test different skills, etc. So when you're going through these, do as many as you can, or do as many as you need to feel confident in the material. Okay, you don't have to do every single one, but if you're finding you're kind of challenged, you're finding some of these a bit of a challenge, then please make sure you go through them. But if they're super easy for you, don't spend tons and tons of time on them. Go through, do a few from each category, from each question, and move on. The idea is to give you enough practice to make you feel confident and enhance your skills, not to bore you to death. Okay, so thanks for watching, and we'll see you in the next lesson.